These are your 8-2 notes. Today we're going to learn how to add and subtract rational expressions. So once again, we're going to use regular fractions and the principles of adding and subtracting numeric fractions to help guide us when we go to add and subtract rational expressions. So they follow the same basis. So when you're going to add or subtract fractions, it requires that you have a common amount. So if I have 5/7 of one and 1/7 of the other, I can tell you how much I have in terms of sevenths. I have 6/7 left. So you just add the numerators together, and then the parts stays the same. So you don't change the denominator, but they have to have the same denominator. In the second example, we don't have the same denominator, so we need to create a common denominator. So you look for a common denominator that both 3 and 5 go into. It has to be bigger than 3 and 5, or at least the same size as 1. And I notice that the smallest number that they both go into is 15. Now, the reason we're looking for the smallest number is just you don't want to have to reduce later on. So they both go into 30, they both go into 300 or 60, but then you're going to have to simplify your fraction later on. So there's a benefit of finding the smallest number that they both go into. And so the least common multiple or least common denominator is 15. Then what I want to do is I want to change 2/3 into 15ths. So I write a little proportion and I say, what do you multiply 2/3 by to make it equal 15? And I do the same thing with 4/5. I say, what do you multiply 4/5 by to make it equal 15? So the rule of fractions says whatever you do to the bottom, if I multiply 3 by 5 to get 15, I also have to multiply the top by that same amount. So I get 10/15. I know it's unsimplified. I know it's not in the most simplest form, but that's the whole purpose. If you simplify it, you're going right back to 2/3, and that's not what I'm concerned about here. So don't simplify after you've made it the other way. 5 times 3, so 4 times 3 gives me 12/15. So now that I have common denominators, if I want to add or subtract them, I would take the 10 and the 12, add those together, and keep the denominator. At this point, in the end, if I could simplify, if I could factor out a common factor, I would. Now, we've learned over time that we just leave it as 22/15. We don't change it to a mixed number, but you could. So just to kind of break that down now in rational expressions, you're going to factor each denominator. We're going to leave the numerators alone because we need to multiply, we need to combine like terms. So you're only going to factor the denominators so that we can find a common denominator. It's much easier to figure out a common denominator if you're looking at the factors. What factors do they have in common? You're going to find the LCD, and then we're going to multiply each fraction by the missing factors. And then we just add or subtract the numerators. So if you look at the last example, we had a fraction with 3 and we had a fraction with 5. The missing factors were each other, right? This one has the factor of 3 that makes 15. It was missing the factor 5. And this fraction has the 5. It was missing the factor 3 to get the 15. So it's sort of that same concept, but now our factors are going to be x plus 5, x minus 7, those sort of things. So let's go ahead and try it. I'm going to start you off with one of those crazy monomial ones because the book likes to throw those at you. So what I have is I want to factor all of this information. So I kind of keep that in track in terms of a little chart down below. So 10a, if I factor 10a, I can just break it down into 2 times 5 times a. And 5b factors to just 5 times b. So they share that common factor. We have to include it. We can't just get rid of it, but I don't have to include the 5 twice. So any common factors they can share, otherwise you're going to get too big of a number. So I want to include the 2. The 10 needs a 2, the 10 needs a 5, and the 10 needs an a. The 5 needs a 5, but we're going to share with the 10, and we need a b. So my least common multiple, or my least common denominator, is going to be 10. Because 5 goes into 10 and 10 goes into 10, but I also, the one needs an A and the other one needs a B. So 10AB is my least common denominator. So if of the 10AB, I'm missing a B in the first one, so I'm going to multiply by B. Whatever I do at the bottom, I have to do the top. And so what I end up getting is 9B over the common denominator. Now I'm actually going to just write down least common denominator so that we don't like cross off those b's before we need to. So I'm trying to help you not cross things off until the very end. 5b, in order to make 5b turn into 10ab, I need a 2 to make the 5 times 2, 10, and I need an a. So I'm going to multiply both top and bottom by 2a. And so what that becomes, 4 times 2 is 8. A times a is a squared over least common denominator. It was subtraction, so we're still subtracting. Now that I have a common denominator, I'm going to subtract the two numerators, which means I'm just going to write them over as one fraction. Now that we're all done, I don't see anything else that we can do. We cannot combine like terms. I'm actually going to write 10ab as my denominator, so 10ab. You can't cross anything off because this is one whole quantity, so unless we could factor something out, which we can't, we're done. Let's look at number 2. Okay, so number 2, when I factor, I can take out a GCF out of here. I'm left with 2 times the quantity, y minus 5. So the first fraction needs a 2, and it needs a y minus 5. The second fraction, when I factor that, I get what multiplies to give me negative 15 and adds to give me 2. Well, I need a y and a y to make y squared. And to get negative 15 and a negative 2, that's going to be a minus 5 and a positive 3. When you add those together, you get negative 2, and when you multiply them, you get negative 15. So the second fraction needs a y minus 5, and it needs a y plus 3. They can actually share this y minus 5. We don't need 2 y minus 5s. So my least common denominator is 2 times y minus 5 times y plus 3. I need all of it. Okay, so the first fraction needs the 2 and the y minus 5. The second fraction needs the y minus 5 and the y plus 3. And so they're going to share the y minus 5, and this is my new least common denominator. So looking at this first original fraction, it's got the 2, it's got the y minus 5, it needs the y plus 3. So I'm going to multiply the top and bottom by y plus 3. So I just kind of squeeze it in here. And when I go down below, I'm going to actually FOIL that so that it's nice and cleaned up, and I'm going to write it as over LCD. So when I FOIL y plus 3 times 3y plus 1, I get 3y squared plus y plus 9y plus 3. I just FOILed. Okay, if you want to write it down before you FOIL, that's fine. I'm going to clean that up in a little bit. I can see the y and the 9y can cancel, but you do too much too soon and you get lost in the problem. Write it as least common denominator for right now, because number 1, you don't want to cross things off that you shouldn't, and number 2, it just saves you time. Write LCD rather than that whole denominator. All right, the second fraction has the y minus 5, it has the y plus 3, it just needs a 2. So if I multiply the bottom by 2 to get a least common denominator, I got to multiply the top by 2, and so that just becomes plus 2 over least common denominator. So now my next step is just to combine those. So I'm adding these two fractions together. I'm going to combine like terms. I'm going to put those y's together, and I'm also going to put this 3 and 2 together. So I end up with 3y squared plus 10y plus 5, and I'm done. So now that I can see that I'm finished, I'm just going to write down 2y minus 5 and y plus 3. Now technically we should look to see if this top could factor. It doesn't, so we're good. Because if it could factor, we could factor something out, we should. And there's your answer. Let's try a couple more. So number 3 here, it factors. This is a difference of perfect squares, x plus 3, x minus 3. The second fraction factors to 2 times the quantity, x minus 3. So my least common denominator, they each need a minus 3 so they can share that. So I need a 2, I need an x plus 3, and they can share the x minus 3. So there's the least common denominator. The first fraction just needs the 2. It's missing the 2. So if I multiply the bottom by 2, I multiply the top by 2, which means I'm going to distribute. And so I write that down below, 2x plus 2 over least common denominator. The second fraction has the 2. It has the x minus 3. It needs the x plus 3. So whatever you do to the bottom to get a common denominator, we're going to do to the top. So I'm going to multiply the top by x plus 3, which requires FOILing. So I get, this is a subtraction, now I'm going to subtract that entire quantity. So I'm going to put parentheses around it. X squared plus 3x plus 5x plus 15, all over least common denominator. So I wanted to show you subtraction because when you subtract, I have to subtract that whole quantity. I'm just going to clean this up and call that a positive 8x. And before I actually do the subtraction, I'm going to write it as one great big problem because every sign of this quantity is going to change. So I'm going to take that extra step to distribute that negative through so I don't mess this up. 2x plus 12 from the first fraction minus x squared minus 8x minus 15 all over least common denominator. My last step is to just clean up. So I'm going to put the x squared out in front. So it's a negative x squared out in front. I've got a 2x and a negative 8x makes negative 6x. And I've got a positive 2 and a negative 15 makes negative 13. And now I'm going to bring in the 2x plus 3, x minus 3 from my denominator. I got to quickly look and see what multiplies to give me 13 and adds to give me negative 6. There isn't anything. We're just looking, could this numerator factor, where let's just say that it had an x plus 3 in it, where we could cross off these x plus 3s. But it doesn't. We looked. Sometimes they like to sneak them in there. So we looked, and nothing factors. So this is your final answer. One more problem. So in this case, it looks like I see those 8s and 7s, and I actually see the opposite sign. So if you notice that this is an a plus 7, and this looks really close to a plus 7, but if you notice, this is a positive a, and this is a negative a. This is a positive 7, this is a negative 7. This whole denominator is the opposite of the first denominator. There's a better fix in finding a least common denominator. If we factor out a negative 1 out of that denominator, this 7 becomes positive, the a becomes positive, and now they are the same denominator. So what do we do with that negative 1 we factored out? Well, when you have a negative fraction, you have some choices. Right now, the negative's in the denominator. We can push it up with the 5. Better yet, we can push it with the symbol. So if you add a negative, it turns this whole problem into a subtraction problem. So what we have in a quick fix of just factoring out a negative 1, we have 2 over a plus 7 minus 5 over a plus 7. So much easier than getting a complex common denominator. So all we did was factor out a negative 1. That changes the operation. So in this case, it was an addition, so now it's subtraction. If it was subtraction, we would be subtracting a negative. It would turn it into addition. And we have a common denominator. So 2 take away 5 is negative 3 over a plus 7. So just kind of have a special eye for those. Look for those opposites. It's way easier to get the denominator that way. All right, so your lesson summary today. I want you to figure out the common denominator for that particular rational expression, but we're not going to add that one together. So I just want the common denominator there. So you got to factor those denominators, and then we're going to do this crazy monomial one. So I want you to actually add those two together. Good luck.